Welcome back, students. Today we'll be continuing with working with the matrices. Let's start with revisiting the colon operator, and we'll see how to use it in different situations. When using when using this colon operator with a vector, you can use it to. So this colon operator is mainly used to specify some range of indices while we are accessing a vector or a matrix. It can also be used to generate a series of numbers. So let's see an example. Let's suppose if I write x is equal to 0 colon 5. Okay, let's see what it generates. Now in this case you can see that this x is now a vector ranging from having values ranging from 0 to 5 with the default step size of 1. Okay, so as you can see here, now you can specify any step size. Let's suppose if I specify the step size of 2, then it will generate only 3 elements starting from 0 ending at 5 and incrementing each step by 2. So it starts with 0, adds 2, so it will be 2, and then adds 2 again, then 4, adds 2 again, becomes 6, which exceeds this last value here, specifying the range, so it does not generate any more values. You can specify any range or the step size. Let's suppose if I specify a negative step size here, obviously it will not generate any element. As you can see, starting from 0 up to 5 with the step size of -2, so it won't generate any elements in this range 0 to 5. Now if I specify 5, x is equal to 5 to 0 with a step of -2, or let's suppose -1, it generates this range, okay, starting from 5 to 0 with the step of -1. So it decrements each element by 1 and keeps on generating the values as long as the range, as long as the values lie within the range. Now there is another inbuilt function which performs a similar operation, and it's known as line space. So it takes an interval. So let's suppose I give the interval 1 and 5, and let's see what it returns. It basically returns, by default, it returns 100 values within the range that has been specified, the interval that has been specified. So starting with 1, it increments, it basically performs divides this interval by 100 in order to extract or determine the step size, and then starting from this initial value, it generates these values by incrementing each value by that step that it has identified. I said by default it generates 100 values, so it would be 5 divided by 100 would be the step size, and intermediate values will be generated accordingly. You can specify the number of values explicitly. So if I say line space between 1 and 5 with, let's suppose I ask it to generate 5 values, so obviously it will generate values ranging from 1, 2, 3, 4 and 5. Okay, so similarly if I say generate 3 values, equidistant values between this interval 1 and 5, so it should give us 1, 3 and 5. So these are some simple functions that you can explore yourself. Now again, using this colon operator, in let's suppose we define a vector, vec1 is equal to, let's suppose 3, 4, 5, 6, 7, 9, and if I want to access all the elements of this vector, I can simply write vec1. It displays all the elements in the form as it is. For example, if this is a row vector, the values will be displayed in the form of a row vector if I specify the name of the variable only. Now if I use a colon operator here, vec1 of colon here means all rows and all columns, as I talked about earlier. But let's investigate a little bit more how it works. So it says all rows and all columns. In fact, the output of this is different from the output that was given when we specified the vector variable name only. Okay, so how does it basically work? This colon means we are trying to traverse this vector uh, one row and one column at a time. So let's take the first row. It only has a single row in this vector. So it takes the first element of the first row and the first column. So it displays 3. Then it takes the second element of the first row. Okay, or we can say the second column of the first row. So it displays a 5. Okay. Similarly, it takes the second element or the second column of row 1, displays 6, then 7, then 8, and so on and so forth. Now, the values that are displayed by using this syntax actually follow the index organization, of the values within a vector. So this is index number 1, index number 2, index number 3, index number 4, and index number 5. The output would be a column vector in the same order as that of the indices have been assigned to the values. So the first value is at index number 1, the second value is at index number 2, the third value is at index number 3, and so on and so forth. By default, it displays this values in the form of a column vector. Now let's see how it works with the matrix. So let's suppose M1 is a matrix. Okay, I'll say it contains 3, 2, 3, 4, one row, and 5, 6, and 7 in the second row, and 1, 9, 0 in the third row. So this is a matrix here. Now if I ask MATLAB to display all the elements of M1 by only specifying the variable name, it adheres to the row and column organization in the matrix. So it displays the matrix the same way as, or I can say that it displays the matrix in subscript form. Okay, we can say that this is index 1, 1, this is index 1, 2, this is index 1, 3, this is index 2, 1, meaning the second row and the first column, and so on and so forth. But if I ask MATLAB to display the elements of M1, all elements specified by this colon here, it means all rows and all columns. Now, as I said earlier, it selects the first row and then starts displaying each of the values in the respective columns. Then select the second row and each of the values in each of the columns. Now let's see how it displays this. As you can see, it again displays a column vector, and again I'll say that it follows the index order of the matrix in order to display these values when we use this colon here. So I already told you that the matrices are stored in MATLAB in column major form. So the index of this element would be 1, this would be 2, this would be 3. Okay, that's how the order has been followed by this colon operator here. This has at index number 1, index number 2, index number 3. So this has index number 4. That is why this is the fourth element in this column vector. This is index number 5. So that's why it is the fifth element here, and so on and so forth. So that's how colon can be used for displaying the elements of a vector or a matrix in their index index order. Now again, I've also told you how to access the elements of a matrix using this colon by specifying the range. Let's see an example again. So M1 of row numbers 1 to 2 and column numbers 1 only. So row numbers 1 to 2, this is row number 1, this is row number 2, and within these rows we are only asking for column number 1. So that's why 2 and 5 elements are specified or displayed. Now again, the submatrices can be extracted from a matrix using the same colon operator, or there is an alternative way as well using square brackets. So if I see what's in M1, so if I want this submatrix here, this one, 6, 7, 9, and 0, I can write M1 of, this is from rows 2 to 3 and columns 2 to 3. So I'll write 2 to 3 rows and columns 2 to 3. So this is the submatrix here. The same thing can be achieved if you specify the row numbers and column numbers in square brackets within the parentheses. So I'm asking MATLAB to display row numbers 2 and 3 from M1 and coincided with the column numbers 2 and 3. Okay, so again it gives the same value. Now arbitrarily you can access row numbers 1 and row numbers 3, okay, without using row number 2. So it should give us 2 3 sorry 5 1 and 7 0. Okay, we specified 1 and 3. So 1 is row number 1 here and 3 is row number 3 here. So 3 9 and 4 0. That's what the output is. So this is all about extracting sub matrices from a matrix. There is another operator that can be used while accessing elements in the matrix, and it's known as AND, and it simply points to the last index of a specific dimension. So let's suppose if I say let's see what's in M1. M1 contains this matrix, and if I write M1 of 1 to end here is the keyword, okay, and end to 1. So I'm asking MATLAB to display rows from 1 to end. End in this case is 3. Okay, so we have 3 rows here. So 1, 2, and 3. And I'm asking MATLAB to display columns in the reverse order. There are 3 columns. So I'm asking MATLAB to display columns in reverse order. So it would be 3, 2, and 1. So we'll get the matrix, in kind of a mirror form. Okay, so I had to specify a negative step here. By default, it does not, it uses a step of 1. So I have to specify a negative step here. So I'll write -1 from 3, 2, and 1. So now if I look at the output, you can see that the columns have been reversed. They have been simply mirrored. That's all about using AND. Now let's suppose we want to delete some specific row or column in this matrix, and let's try it again. Let's see what M1 contains. So let's suppose we want to delete this column, the third column of this matrix. So what we can do is we can ask MATLAB that M1 of all rows but the third column is equal to an empty vector. Okay, so we want to delete this. So I'm asking MATLAB to set all rows and third column elements in all rows but the third column to an empty vector. So it should simply remove this last column from this matrix. So that's what we get here. Similarly, you can delete a row. So M1 of 2 comma now let's try to investigate if I want to delete a single element in this matrix. So I want to delete 2 comma 5. Okay, sorry, 2 comma 3 means second row and the third column means this element. I want to delete this element and set it to an empty vector. However, the problem is if I delete this vector or this element from this matrix, the dimensions, the dimensions of the rows would not agree. It means that this row would have 3 elements and this row would only have 2 elements and the third row would have 3 elements. But matrices, for matrices it's important that all rows have the same number of elements, or we can say that all columns should have the same number of elements. So this operation would violate that. So that's why MATLAB does not agree to to this operation. Okay, so let's try to delete a row in in this matrix M1. So delete row number 1 and all columns and set it to this null vector. So you can see that earlier M1 became 2, 3, 5, 6, 1, and 9. Now we have deleted the second. Now that we have deleted the first row, okay, as you can see, first row on all columns to null, so it becomes this matrix here. In order to find the dimensions of matrix, we have the size function. So if let's suppose we let's find out what's in M1. So M1 right now contains this matrix here. Okay, the dimensions of this matrix are that it's a 3 cross 4 matrix. So if I want to find out what are the dimensions of it, so I can write size of M1. So it gives a vector with two elements. The first one specifies the number of rows and the second one specifies the number of columns. So if you want to simply use the number of rows of this matrix, you can store the size in some variable. Let's suppose we'll say siz is equal to size of M1, and the size is a vector, a row vector, wherein the first element specifies the number of rows. And if I want to access that, I will write siz of 1, which will give me the number of rows in matrix 1, so which is 3. Now we can also use length, which is basically a vector function, to find out the number of elements in M1. But in fact, as I earlier told you, that vector functions apply to matrices in column form, column wise. So if I apply this function length, which is basically a vector function to identify the number of elements in a vector. So length of M1 would apply on this matrix column wise, so it should give us the total number of columns in this matrix M1. So that's what it gives us, 4. 4 is the number of columns in this matrix M1. So we're done with identifying the size. Now let's suppose you want to create a matrix and it's too long to fit in a single line, and you want to type in a number of lines, or you want to type in a statement in multiple lines. So for example, if I want to write M2 is equal to, I'll say 3, 5, 6, 7, and then I'll write, if I press enter, okay, although it would work in this case, but it's better if you use let's suppose I'll write the second row as 4, 3, 5, 6, and 7. And in order to tell MATLAB that there is a continuation of lines, so it means this statement spans a number of lines or is followed by some statements in the second line, you can use 3 dots. These 3 dots specify that there is a continuation in the second line. So I'll say 5, 6, 7, 8. Again, I'll specify 3 dots which specify that the statement is still continuing in the next line. So 0, 3, 4, 5, and I'll write the square bracket terminated in this. And if I want to see M2 contains this particular matrix. So we'll later see a much better example of using these continuation operator to tell MATLAB that the statement spans multiple lines. Okay. Now let's suppose I have 2 matrices and I want to concatenate them into a single matrix. So let's suppose we have 2 vectors and I want to build a second vector from I want to build a third vector by combining these 2 vectors. So let's first see how to combine multiple vectors. So if I have probably I already have a vector vec1. Okay, vec1 contains these elements, and let's suppose I design another vector vec2 is equal to some okay, so these are the 2 vectors vec1 and vec2, and if I want to concatenate them, I can create another vector vec3 is equal to, within the square brackets I'll write vec1. So this is one part of the third vector, and the second part is vec3. Okay, sorry, vec2. So if I press enter, you can see that these 2 vectors have been concatenated. So in case of concatenating vectors, it's not necessary that they have the same dimensions. Okay. Now let's suppose we have one of them is a column vector and another one is a row vector. In this case, both were row vectors. We'll try to see if it is possible to concatenate a row vector and a column vector. So vec1. So let's suppose I'll write vec4 is equal to vec1 and vec2, but I'll transpose this vector. Okay, so I'll convert it into a column vector and see whether it's allowed or not. So dimensions of arrays being concatenated are not consistent. So obviously, it's important that when you concatenate vectors, both of them either should be a row, or both of them should either be row vectors or column vectors. Now let's try to find out how to concatenate matrices. So M1 is a 3 cross 4 matrix. Okay, and let's suppose I'll create another matrix M2 with different dimensions. We'll see how it works. 2, 3, 4, and then we have 4, 5, 6. Let's create a 2 cross 2 matrix only. Okay, so this is a 2 cross 2 matrix M2, and we'll try to concatenate M1 and M2. Let's suppose I'll write M3 is equal to M1 and M2. Okay, we can use a comma, or as I said, it's better to use commas when you specify elements in a vector or a matrix. So it does, it shows the same error again, that the arrays that are being concatenated are not consistent in terms of the dimensions. So let's try to give M2 another, let's create M2 as a different matrix, 3 cross 3 matrix, 6, and similarly this one. So this is a 3 cross 3 matrix right now. Let's try to find out whether it is possible to concatenate M1 and M2. Now as you can see, in this case, the number of rows in M1 and M2 was the same. So concatenating M1 and M2 was done along the rows in this case. Okay, now had it been that the number of rows in M2 was a bit different, let's suppose it was 4, okay, 6, and let's suppose 9, and we want to concatenate M1 and M2. Let's see what M1 contains. So both of them are 3 cross 4 matrices, and let's try to find out whether we can concatenate them. Now again, the number of rows in these two matrices agreed. Okay, let's try to mismatch them in terms of the number of rows. So we only have a 2 cross 4. M2 is a 2 cross 4 matrix, and M1 is a 3 cross 4 matrix, and let's try to concatenate M1 and M2. So the dimensions again do not agree. So it's important that I am asking MATLAB to concatenate M1 and M2 along the rows. Okay, but the problem here is the two matrices M1 and M2 do not have the same number of rows. Now if I wanted to concatenate them column wise, the number of columns in both these matrices M1 and M2 was the same, so I could do that. I could concatenate M1 and M2 using a terminator here. In this case, basically I'm asking MATLAB that concatenate M1 and M2 column wise. Okay, this using this semicolon here, not the terminator here, it's a semicolon, row breaker. So in this case, you can see that the two matrices were concatenated column wise. So whenever you concatenate matrices, it's important that you so whenever we want to concatenate two matrices, it's important to see that the dimensions agree. If we are concatenating them along rows, it's important that the number of rows in both the matrices is the same. Similarly, if we are concatenating them column wise, it's important that both these matrices have agree in the column wise dimension. So that's all about concatenating. Now let's see some of the functions. So now let's see some of the functions which MATLAB provides for manipulating or dealing with matrices. It provides functions for creating some special matrices, some arithmetic, performing some arithmetic or manipulations with matrices, and so on and so forth. So we'll explore some of the functions. As I earlier said, that it's not possible to go through all the functionalities of MATLAB, all the functions that it provides in these short videos. but I will just go through some of the functions. Others you can explore yourself depending upon your requirements. So let's start with an inbuilt function for matrices. Let's clear the screen first. So one of the functions is IEYE. Now I here basically stands for identity matrix. Excuse me. Now I here basically stands for identity matrix, and it creates an identity matrix an identity matrix is the one where it's basically the one which has only the diagonal elements equal to 1 and rest of the elements will be 0. So the rest of the elements other than the diagonal elements would be 0. So if I write I of 3, so it will create an identity matrix, 3 cross 3 identity matrix, and display it here, So the diagonal elements are 1, the non-diagonal elements are 0. You can specify a different dimension as well. 3 cross 4, for example, it means 3 rows and 4 columns. Okay, an identity matrix with 3 rows and 4 columns. An identity matrix with 3 rows and 4 columns. As you can see, the 3 rows and 4 columns, and the diagonal elements here in this case are 1, and the rest are 0. Now, we also have another function, zeros. It simply creates a matrix of zeros of the specified dimension. So let's suppose if I write zeros of 4, so it will create a 4 cross 4 matrix of zeros. Okay, you can specify a different number of rows and columns. So if I write 4 comma 3, so it will create a matrix of 4 rows and 3 columns, all filled with zeros, as you can see on the screen here. 4 cross 3, 4 rows and 3 columns, all filled with zeros. Okay. Now we also have another function, ones. Works the same way. It creates a matrix of ones. If I write ones of 5, so 5 cross 5, so 5 cross 5 matrix of ones. So 5 cross 4, a 5 cross 4 matrix of ones in this case here. Now there is this function named as diag, D-I-A-G. Now it works in 2 ways. It either is used to extract the diagonal elements of a matrix, or it's used to create a diagonal matrix. Diagonal matrix is one in which only the diagonal elements are non-zeros and the rest of the elements are zeros. So when you create a diagonal matrix, but when you want to extract the elements from a matrix, it's not necessary that the matrix be a diagonal matrix. It can be any matrix from which you'd want to extract the diagonal elements. So let's suppose we create a matrix. Let's have a look at what M1 contains. M1 is a 3 cross 4 matrix. So the diagonal elements, starting from the top left corner, here are 3, 1 and 2. So if I ask for the diagonal elements of M1, DIAG of M1, it is 3, 1 and 0. So it returns a column vector. Okay, so these 3, 0 and 2, 3, 0 and 2 are the diagonal elements of this matrix. So diag here extracts this matrix, so extracts the diagonal elements from matrix M1. Now if I want to create a diagonal matrix from a vector, so I need to specify what I want to create a diagonal matrix, which means that I only specify the diagonal elements. The rest of the elements will be set to 0. Now if I, let's suppose, specify a vector dig of this cold is very, very bad, sorry for that. So dig 3, 5 and 6 is a vector. Okay, dig in this case is a row vector with 3 elements, and if I ask diag function, or if I pass this vector to the diag function, okay, dig, it should create a matrix with the 3, 5, and 6 being the diagonal elements of that particular matrix, and the rest of the elements would be set to 0. If you look at this result, it creates a square matrix. Excuse me. So if it creates a square matrix with this vector being set as the diagonal elements of that matrix. So let's see some of the other matrix functions. We've seen this identity, diagonal, and okay. So there is this function DRIU. Excuse me. Oh, that was a volley of sneezing. Okay, these allergies. So there's a function TRIU. It basically stands for the upper triangular matrix of an input matrix. So if I, let's see, if an M1 contains, M1 is this matrix here, and if I ask for the upper triangular part of this matrix TRIU of M1, it will give me all the elements in the diagonal and the upper triangular part. The rest of the lower elements would be set to 0. The lower triangular part would be set to 0. So that's what we get. The upper triangular part, we get the diagonal, and the upper triangular part, the lower triangular part is set to 0. Similarly, we have this DRIL, which gives us the lower triangular part of a matrix. So if I pass M1 to it, it gives me the lower triangular part. The upper triangular part is set to 0. It includes a diagonal. Now there is this function which might be used in different situations. It's called the random function. This random basically returns a matrix with the random numbers between 0 and 1. If I let's suppose write RAND, so it returns a single value, a scalar, okay, between a random number between 0 and 1. Next time it would obviously return a different number depending on what seed it has. You can specify the seed for rand as well when you use it as a function. You can explore that yourself. For the time being, I'm just showing you how to create a matrix of random numbers. So if I ask MATLAB to create a square matrix, 5 cross 5 matrix of random numbers, so it will generate a 5 cross 5 matrix with all these random numbers between 0 and 1. So you can have an arbitrary dimension 3, 2, so 3 cross 2 matrix of random numbers. Now if you want, you can scale a random number between any range you want. Let's suppose if you want to have so rand returns a single when you use it as a command, okay, not as a function. It returns a single this random number between 0 and 1. You can scale it between any range. So let's suppose if the range is 10 to 50, so it would be 50 minus 10 would be 40, and plus 10, so it would be rand into 40, 50 minus 10 plus 10. So this would give us a random number in the range 10 to 50. Okay, so you can use this any way you want. So these were some of the functions which are provided by MATLAB. There are so many special matrices functions which you can explore yourself. These were just a few that I talked about, and I guess that's it for the time being, related to matrices. Okay, for today it would be enough. Let's resume back with some other concepts in a later lecture.